Okay, so I'm recording this. This is Mat154 Pre-Calc College Algebra, section 8.4. So let's talk about some of these theorems. First one is the fundamental theorem of algebra, and the way I look at this, if you look in the book, you see that up to this time, we've had, 3x squared plus 2x plus 5 equals 0 or something like that. But we can have expressions that are much more complicated. 5x cubed minus 2x, 2 plus 4i.
Mr. Mitchell.
Yes.
We can't see your screen, where you're writing.
You can't see this.
We can see your face, but not where you're writing.
Okay, let me hit share screen. Can you see it now?
Yes.
You can see this?
Yes.
Okay, good. Thank you. I guess when I went to record it, got knocked out. Okay, so you can have weird looking things. So, we're used to seeing these kind of expressions, but sometimes we can run into the horrible ones, So the fundamental theorem of algebra, the way I look at it, it says, if this power is a 3, you should get 3 answers to this problem. Now, those answers might be nice answers like 2, 3, and 5, or they could be imaginary answers like 7 or complex numbers, or they could be radicals. So it makes it a little harder to solve this kind of problem, or even this problem, because they're not always going to be nice answers, nice whole numbers. They could be fractions, they could be all kinds of things. So we're kind of used to dealing with them when they're just, nice numbers. So now we're going to deal with the bad boys of algebra. Okay. So let's start out with this one. First of all, they give you the answers to the problem. This is example 1. And we know the answers to this problem, but we want to know what is the equation that gave us these answers. The answers were 1, 3i. And I'm going to tell you something. When you have imaginary numbers or radicals, they always come in pairs, positive and negative. Okay, so we see there's 3 answers. So that means that the power was a power of 3. So how are we going to find this? Well, let's put them in factored form first. Factor form. So to put them in factor form, it's always going to be x minus and then the number. X minus and whatever it is. And x minus and the number. So simplifying, and here negative, negative, positive. So that's what we have. These are our answers in factor form. Now we want to put this into a polynomial. Any ideas? Probably not. Okay. So what we're going to do is, usually it's easiest to start with these two numbers that have opposite signs. X minus 3i times x plus 3i. We're going to multiply those together and see what we get. And that's going to get, we could do a short FOIL. I'm going to do the whole FOIL on it, but you can use just first and last, but I'll go ahead and do the whole FOIL. X squared plus 3ix we'll write it like that. Minus 3ix minus 9i squared. I times I. Okay, well, we can see these cancel. What do you know about I squared, though? What do you remember about I squared? It's an I with a dot and a power 2. No, it's -1, remember? I squared is just -1, so let's cross this out and put a -1. So now we have x squared. -9 times -1 is +9. So that's what these two are. Now we're going to multiply that by x minus 1. And we do a FOIL again. X cubed, see, first times first, outside, minus x squared, inside, last term times last term. And there's our polynomial. I like that, polynomial. This means polynomial of x. And this is the equation that would get these answers. These are the roots. This is the function or the expression or whatever you want to call it. We'll call it equation. That, if we set this equal to 0, that gave us these answers. Does that make sense? Nonsense, okay. Yes, well, hopefully it helps. Okay, let's try another one here. So that's how you're gonna, they give you the answers and we multiply them all together, but we have to have them in factored form. All right, let's try another one here. This problem said you have a degree of 5. That means it's going to be a 5th degree polynomial, going to be pretty big. It has a -1 with multiplicity of 3. That means it's happening 3 times. And 0, let's see. 4 with a multiplicity of 1, so we just have a 4. And we have 0 with multiplicity of 0. So what we have here is we have x minus a -1. So we could write that as just x plus 1. But it happens 3 times. Then we have an x minus x. And remember, it's always x minus, and then we put the number in. That's what I did here, x minus and then the number. So that gave us x plus 1. Maybe I should write this next to it. 3 times that happened, x minus 4. And then finally we had an x minus 0. So x minus 0 would be just x. All right, so how are we going to figure this out? Well, just a ton of multiplication is what it is. We got to multiply all these together over and over and over again. So you got to multiply these two, then that answer times this, then that answer times this, and then finally the final answer by just x. And that'll give you your equation. So let's try it. Well, these two, using a little shortcut, this is going to be x squared plus 2x plus 1 times x plus 1 times x minus 4 times x. Let's go ahead and multiply these two together. That's going to be x squared minus 3x minus 4. If you mess around with it and do the FOIL and all that good stuff, that's what you're going to end up with. So you're going to have to multiply these two together and then this. You can do them in different orders, but that's what's going to happen. So let's distribute the x squared to this one. X to the fourth minus 3x to the third minus 4x squared. So I'm distributing this x squared to each term. Now the 2x. This will be a 2x cubed. I put it right here. And a minus 6x squared and a minus 8x. And then I'm going to distribute the 1, which is easy, huh? That'd be plus 1x squared minus 3x minus 4. So I multiply the x squared times each thing, the 2x times each thing, the 1 times each thing. I still have this x out here that I didn't use. X to the fourth minus x cubed negative 10, take away 1 plus 9 minus 11x minus 4. Then I'm going to multiply everything by x to get the final answer. That just increases the power sum. And that should be my polynomial. And hopefully I got it right. 5, 4, 3, 2. Actually, I did. A shock. So you can see it's kind of time consuming. But fortunately, these were just nice numbers. What if they're not? Now the fun begins. Okay, so it's a little time consuming. You can do this different ways, but you just got to multiply all these together. And just remember x minus 0 is just going to be x. So that saves a little bit of work. All right, so bingo. What if we had an equation and the answers were negative radical 3 and 1 plus I? And it says, write an equation that has these answers. Well, remember these always come in pairs. Okay, so this is negative radical 3. You're going to have also positive radical 3. And if you have 1 plus I, you're going to have 1 minus I. So your equation has to be to the 4th power, because there's going to be 4 answers to it. Let's put them in factored form. X minus negative radical 3, x minus positive radical 3, x minus 1 plus I, it should be like that, 1 minus 1 plus I, and x minus 1 minus I. So that's tricky in itself, just to get them in factored form. X minus the negative radical 3, x minus the positive radical 3, x minus the 1 plus I, x minus the 1 minus I. Notice the conjugates of each other conjugates have the same first term, but then the last terms are opposite. The imaginary or the radical, the real terms don't change, just the back terms. So let's simplify this a little bit. X negative negative plus x minus, how about this one? X minus 1 minus I. X minus 1 plus I. Well, let's deal with this group first. Okay, let's look at these two. If I'm going to multiply them, I can do the whole FOIL if I want. But I could also do, because these are difference of squares, I can just do the first times the first and the last term times the last term. Radical 3 times radical 3 is radical 9. But the square root of 9 is what? 3. So this is x squared minus 3. I'm doing a short FOIL. First times first, last term times last term, and then simplifying it. So that's what this group would give me. Now, what about this mess? Well, here's where we do our detective work. We notice that these two terms are the same. And then there's a minus and a plus. So this is, we can think of this as x minus 1 minus I, x minus 1 plus I, difference of squares. So this gives me, if we're going to do the short FOIL, x minus 1 squared minus I times I squared. So this is a unique little factor pattern. X minus 1, x minus 1, x minus 1 squared, I times I. I told you it's going to get harder. Okay? Now let's expand that out. What is x minus 1 squared? Well, that's a squared of a square. Square. Multiply these together and double. And then square. Negative 1 times negative 1 is plus 1. And I squared, what do we know about I squared? I squared is negative 1. So this would be minus a negative 1, which would be plus 1. Now I have x squared minus 3 times x squared minus 2x plus 2. Now all I got to do is multiply this together. Easier said than done. Let's put it up here. Well, maybe I have enough room. I'm going to multiply the x squared times each term. X to the 4th minus 2x cubed plus 2x squared. Now I'm going to multiply the negative 3 times each term. Negative 3x squared positive 6x and a negative 6. I put these two terms under each other so it's a little faster to do. X to the 4th. This is my polynomial now. X to the 4th minus 2x cubed plus x squared plus 6x minus 6. And I have a mistake right here. This should be minus. There we go. Negative and a positive. So this is my answer to the problem. Pretty simple, huh? No, I know. It's always difficult when you have something like this. If you just had like 2i or 3i, it won't be so hard. But when you have something like this, so notice what we did. We put it in factored form, but then we looked for a relationship here where these two terms were the same and these were opposite. This part wasn't so hard, but this part a little bit more confusing. So that's something you're going to have to work on a little bit. Try some of those. Then it says try exercise 39, and there's something like that. That you might have to do 3 or 4 of those to get used to seeing that. Once you get used to seeing them, they're not so bad. But the first time you see it, it's like pretty overwhelming. Will this get worse? Yes. Okay, we have one more thing to do here. They gave you the answers. What if we had this polynomial and we wanted to solve it? How are we going to do that? So that's what we're going to try to do. We'll do a simple one, and then maybe tomorrow we can do a more complicated one. So let's suppose you were coming home from school and you saw this piece of paper on the ground and you picked it up and it had this function. And it said, win $5 if you can solve this problem. Let's hope I didn't give you a super hard one, which I think I did. Unfortunately, this one's pretty hard, but maybe we won't solve the whole thing. First thing we want to do is we want to check out possible answers to this thing. So we have a technique for finding the possible answers. It may be that none of these work. It may be that several work. We don't know. This is called P. This number in the back, just a 4. And the number in front is called Q. Possible answers are P over Q. So we're going to find all the factors of let's keep the -4. -4. So 1 times 4 would give me -4, right? Could it be a +1 times a -4? Or it could be a -1 times a +4. So we always with these, it's plus or minus. Because even if this was a positive number, a negative times a negative could give you a positive. So we always with these plus or minus. Is there another number that would go into 4 evenly? You can divide 4 by 1. You can divide 4 by 4. You can divide it by 2, plus or minus 2. So those are called the factors of 4. What are the factors of 3? Well, you can divide it by 1, and you can divide it by 3. So what are the possible answers? I'll put them down here. It could be all these numbers right here divided by 1. So it could be plus or minus 1 divided by plus or minus 1 is going to be plus or minus 1. Plus or minus 2 divided by plus or minus 2 is going to be plus or minus 2. Divided by 4, 1 into 4. But we could also divide every one of these numbers by 3. Yes, they could be fractions. We could divide the 2. Or we could even divide the 4 by 3. So this gives us a list of candidates of possible answers to this problem. But some of these answers might be imaginary. They might be radicals, and they're not going to show up here. These are just possible rational numbers, okay? But they could be irrational, or they could be complex. So we don't know, you know. So it's kind of a guesswork thing. So how do we tell now which one of these work? We do it by trial and error. We try each one. We're going to try one. And we're going to divide that by 1. Now, we only needed the coefficients. I don't know why I wrote all that down. Oh, maybe it's a good thing I did, because look at right here. I'm missing the term. 4, 3, 2, 1, 0. So let me try this again. 1 into 3, negative 11, 0, 10, and negative 4. 4, 3, 2, 1, 0. All right, let's try it. 3, negative 8, negative 8, negative 8, negative 8, negative 2, positive 2, 2, negative 2. No, we wanted to come out 0. That's not a factor. So we're going to try another one. So this didn't work, and sometimes it doesn't. So now we're going to try negative 1. It'll be 3, negative 11, 0, 10, negative 4. I want to wrap this up pretty fast. And then we'll finish this problem out tomorrow. Bring down, multiply, calculate, multiply, calculate, multiply, calculate. I think I made a mistake here somewhere. Oh, right here, there should be a positive 4. Right here. No, this would be a negative 4. And a negative times a negative is positive 4. There we go. And there's my answer. Yes, I wanted to be 0. So now we work down this equation. We want to use this new one. So this is the power of 3, then 2, then 1, then the whole number. So this is the polynomial I have now. I know negative 1 is one of the answers. Negative 1 might work again. We don't know. We have to test it. If we could factor this down, we would factor it down, but unfortunately we can't. So we're going to have to keep trying numbers until we hit one that works. So the next number we're going to try in here, I try a negative 1, I try a negative 2, a negative 2, a 4, a negative 4, a 1/3, a negative 1/3. Finally, I'm going to try a 2/3. Going, oh my goodness. So it's a trial and error method. There is no fast way of doing this. Let's go with this equation right here. You don't need this 0. Cubed. All right. So we bring down 3. 2/3 times 3. 2. Negative 12. 2/3 times negative 12. Negative 4 times 2. Negative 8. 6. 2/3 times 6, 4, 0. So this is another solution. Then when we get it down to this point, we're going to try to either factor this or use quadratic formula to solve this. This one we have to use quadratic formula. And we'll pick that up tomorrow because we're running out of time. So tomorrow we'll see if we can finish this problem using the quadratic formula. So you can see this is it's a time consuming, but we can actually try to solve these problems, but they're very difficult. And the higher the power, obviously, the more difficult it gets. All right, so I'm going to sign you off. Let's see.